We're going to look at some things about altitude proportion theorems. So one of the theorems here has that if the altitude to the hypotenuse of a right triangle forms two triangles that are similar to each other and to the original triangle. So in this triangle that they've given us, if CD is the altitude here, altitude just means that it meets another side of the triangle at a right angle. And these little squiggly marks in between here mean similar. This means similar. So triangle ADC, I'll mark that in red. So ADC, that triangle is similar to triangle CDB. And then also triangle ACB, which is this whole big triangle, is similar to triangle CDB, which is the blue triangle. So we've kind of got three different right triangles that are all similar to each other with this theorem. There's an IXL link that you can do to get some more practice on this. You can just do a search for that code or type in the words about it, but otherwise we're going to look at some problems on a worksheet here. So here's a little bit of notes to start with. It's already mentioning what we just talked about those three triangles being similar to each other, and then they mentioned here about the large triangle, the left triangle, and the right triangle, and there's some information there. This is something in high school in geometry that you do as proofs to like prove different things. So this would be examples of their steps for proving that these triangles are similar to each other, and it basically has to do with the angles being the same as each other. The right angle is a big help. We know the right angles are congruent to each other. Angle A is congruent to itself here, so there's another angle that's the same on both of these triangles. And then if you know two of the angles are the same, there's 180 degrees total in the triangle, so if two are the same, that third angle, what's left, is going to have to be the same angle measure as well. And then it's similar idea if you look at what they've got for that the last two there. And this is stuff that's on your worksheet, but I'm just going to show it to you a little different here. If you look at this example, they want us to find the value of x. So this is going to be probably more so what they're going to ask us to do is finding the value of a side length. What you can do, the book just separated the triangles. Besides just separating them, if it's helpful to you, I find it helpful personally to also rotate the triangle. So if you'll notice the angle measure here, we have this angle and this angle that are marked to be the same as each other. So I just turned the triangle on the left. I just turned that, rotated it 90 degrees. And then once we do that, we could do a proportion once we know that those triangles are similar. So here's the proportion they did. So the 4 matches up with the x, that's their first fraction. And then the x matches up with the 16. So 4 matches with x, x matches with 16. These are both from the big triangle. These are both from the small triangle. Now, the issue we have at this point is that we have two x's here. Normally, we've just had one x, and we find a pattern, and we figure out what it's equal to. In this case, we have an x in a numerator. We have an x in the denominator. So we can't figure out, if we don't know what x is, we can't find a pattern for between 4 and x, or between x and 16. So this is one case. I know I kind of skip over this idea a lot of times, but this is one case where we are going to cross multiply. So cross multiply means we can multiply diagonally Multiplying diagonally, that seems like not math, really. So let me just explain real quick why cross multiplying works. And it's fine to do, but just understand it's not just a magic trick here that we're doing. Basically, what cross multiplying does is it takes, and I know it doesn't look like this, but just bear with me. It takes the two denominators and multiplies them together. So in this case, we have an x and a 16. So if you multiplied those together, that would be 16x. So imagine for a minute if we take both of these fractions and multiply them by 16x. And I know you're thinking, there's no 16x in what we just did with cross multiplying. Where are you going with this? Well, just stay with me here. If you do that, here the x's can cancel. The factor of x can cancel numerator and denominator, just reducing it. And so we're left with 16 times 4. 16 times 4, look, 16 times 4. On the other side, the 16s can cancel out. And we're left with x times x. X times x, oh look, x times x. Okay, so this cross multiplying, it's kind of just a shortcut that somebody found probably when they were deciding to be lazy about working stuff out or whatever. It's kind of an interesting idea, but that's kind of why it works instead of just we're randomly multiplying at diagonals here, which doesn't seem like normally what we would do. Once you get to that point, you know x times x, something times itself is something squared. So x times x is x squared, and then 4 times 16 is 64. So if x squared equals 64, you might be able to just think about what it is. Otherwise, if something's being squared, we want to do the opposite operation, and so that means we need to take the square root. Technically, when we add the square root, we should add plus or minus, even though we know we can't have a negative length here. Square root of 64 is 8, so 8 would be the answer or the value of x for this problem. And then once you get the answer, you might want to just go back and look in the picture. We can't always judge things by their pictures, but you can look at the picture to see visually if it makes sense, the length that we came up with. So if I can get this to pull back over here. Okay, so you might notice the 8, dimensionally, it seems like 8 would be a reasonable length for these missing sides if this was 8 and if this was 8. It's longer than the 4, but it's shorter than the 16. And then if you had time, which you're not going to probably at that point, you could then also look for patterns. So if this was 8 and this was 8, well, you might just notice 4/8 and 8/16 are both the same as 1/2. Or you could just divide them out. Whatever decimal you get should be the same for both of them at that point. So if we look at number 2, we're finding the value of x. So what I did is highlighted a triangle in red that I'm going to redraw over to the side here and just turn it. And so imagine that triangle and then the left triangle, I guess I'll make in blue here. And we're trying to make up a ratio with those. So what I did is just took the, from the big triangle, we have an x that matches up with the 2 over here, and then the 18 matches up with the x. So that would be a proportion. We have x's both in the numerator and the denominator again, so we can cross multiply, or however you want to do that. So now we've got x squared equals 36. We do the square root. Square root of 36 is 6. Technically, we added the square root. We'd add a plus or minus, but we know we can't have a negative length. So we've got x equaling 6. If you substitute that back into the proportion, you've got 6 divided by 2, which is 3. 18 divided by 6 equals 3. So we should be in good shape. We can also look at this on the picture and see if 6 seems reasonable compared to the other lengths that are given, and it looks pretty good. Number 5 is going to look a little bit different here as we work this out. So I'm just going to redraw that. What you'll notice is different here is that we know 2 of the sides of that triangle. There's no X in that, and that means that really we could just do a pattern at this point. We could just look, how do I get from 8 to 12, and then we'll use that pattern to go from 12 to X. So if you do 12 divided by 8 is 1.5. So it means we're multiplying by 1.5, and then 12 times 1.5 would be 18. So X equals 18. If we look at number 6, we're going to do the same idea here. So I'm going to take this on the left side, and I'm going to redraw it. If you want to redraw it below, if that's easier, wherever you want to draw it on your paper. But this would just be a thing you'd want to do just probably right at the beginning. And you don't have to do it, but like I said, to me, I just have a hard time. If I don't have it actually turned on my paper, I have a hard time getting things to match up. This one, we do have an X on both triangles again, so we're going to be back to our cross multiplying idea. So if you'll notice here, so the X matches up with the 9. That would be this left side here. X matches with the 9. And then the same order, the 12 matches up with the X. So this could be our proportion, and then we can cross multiply. So X squared equals 108. We do the square root. And actually we can't get, well, negative doesn't work. A number times itself to get 108, that doesn't come out evenly. This would be about 10.4. Probably what's going to happen is you can look for this, but they're probably just going to leave the answer as square root of 108, or potentially what they could do also, we mentioned on some previous things we've talked about, they might actually rationalize this a little bit or simplify this down. So square root of 108, we could look for perfect squares in it. So square root of 108, 108 is 9 times 12. And then what you're allowed to do is break this up. The square root of 9 is 3. And then actually the 12 still has a perfect square in it. There's still a 4 in there. So square root of 4 is 2. So this would be equal to 6 times the square root of 3. So 6 times the square root of 3 is what you're likely to see on the answer choices. But what I would suggest, rather than going through all of that process, you're not going to have time to do that. So what you could do, just do square root of 108 on your calculator and get that it's about 10.4. And then try the answers that they put in or that they have as options. So try 6 times square root of 3 on your calculator, and you should get the same answer, about 10.4. That's going to be much quicker probably than trying to go through that whole process. Number 7, same idea. All these we've involved the same type of situation with the triangles. We do want to remember technically that the other, like if you flip upside down with that other right angle, like triangle ABC, that triangle is similar to these as well. But so if you look at this one, we've got this matchup. So X, technically we could just do a pattern from this point. This is dividing by 2. So then 8 divided by 2 would be 4. We'll look at number 8. We're going to do the same thing. So if I redraw that triangle, the x matches up with 6, and then same order, the 6 matches up with 4x. So look at this again, x matches up with 6, 6 matches up with 4x. So this is a little bit different because we don't just have an x, we have a 4x there. The idea is the same. We're going to do x times 4x equals 6 times 6. When you do this, x times x is x squared. That 4 is just going to stay out in front of it. So that's 4x squared. 6 times 6 is 36. And then what you would want to do here is first divide by 4. So x squared equals 9. And then we could do the square root. Square root of 9 is 3. And we know the negative answer doesn't work. So x equals 3. Would be our answer for this one, and we could check this out over here or back in the original picture and see if 3 looks right. This is 4 times 3 would be 12. If you put it back in the original proportion that we had, if x is 3, 3/6 is the same as a half or 0.5. And this would be 6 over 12, which is also 1/2 or 0.5. So that looks to be the correct answer for that problem. So this gives you an idea of how to work with altitude proportions. Have a good day.